Welcome to Math 7 Review Unit, Lesson 1, Types of Numbers. The learning targets for Lesson 1. The important thing is that after this lesson, you will be able to identify different types of numbers by their characteristics. You will also be able to determine which number set best represents a given situation. So we'll start with an image of types of numbers. So if I look in here, I can see the whole big picture is all the real numbers. So all the real numbers, that's everything you're going to learn this year. So this entire green box is the real numbers. Now inside that big green box, there are irrational numbers. Notice that they are all by themselves over here. Those irrational numbers are numbers that never end and never repeat. Inside this other situation, we have the naturals. Those are the ones that you learned when you were really little, your counting numbers. The whole numbers are right outside of the naturals, and all you do is add 0 to them. So the whole numbers are the naturals plus 0. The integers, you add the negatives. So they're called the whole numbers and their opposites. They also include 0. And rational numbers are any numbers that can be written in a fractional form. So 2/3, 6 1/4, or a decimal form, because a decimal could also be written as a fraction. As long as it never ends and never repeats, then it would be an irrational number. So for it to be rational, it has to end or repeat. So let's take a look at filling this in. So we'll go to natural numbers. The natural numbers are your counting numbers. So they are like 1, 2, 3, and so on, counting numbers. And this is my number sign. We know it as a pound sign as well. It's a number sign. Hashtag for you guys. Whole numbers are your counting numbers or your natural numbers plus 0. So you would say 0, 1, 2, and 3. So your naturals, numbers plus 0. I'm a math teacher, so I'm writing as few words as possible here. My integers are my whole numbers, so here they are, and their opposites, so -1, -2, -3. I'm going to leave it at that. My integers are whole numbers and their opposites. I could put it in here, whole numbers and opposites. And my rational numbers are any number that can be written as a fraction. So I'm going to say an example would be P over Q, but my rule is that that Q can't be 0. So it has to be written as a fraction, but the denominator can't be 0 because anything divided by 0 is undefined. So Q cannot equal 0. And if it happens to equal 1, it just turns out to be a whole number or an integer or a natural. Okay? And irrational numbers are numbers that never end and they never repeat. You'll memorize several, but pi and radical 2, and then I'm going to throw radical 5. You'll see that as well. And our next page of that is where we're going to practice. Write all names that apply to a number. So 12 2/3 innings. That would be a rational number because it can be written as a fraction. And it cannot be a whole number, an integer, a natural. The length of the side of a square that has an area of 10 square yards. Well, this is kind of fun. I'll make this a little larger here. So if we have an area of 10 square yards, remember a square has equal sides. So you've got an x and an x. So square equals sides. Your area of a square would be side times side. So you'd have x times x equals 10. We don't yet, you may not have seen an equation like this in 7th grade, but x times x gives you x squared equals 10. So you can say to yourself, what times what is going to give me 10? Or you can take the square root of both sides. We'll learn this officially later in the year. And you say, oh, what is the square root of 10? So this is where you could reach for your calculator and find the square root of 10. And what you're going to find when you do the square root of 10 on your calculator, it's going to be 3.16227766017, and that is an irrational number. It's never going to end and it's never going to repeat. So you would say that that is irrational. It's okay to write IRR. That's why I left those as capitals. All right, and our last one, let's tell whether this is true or false. All rational numbers are integers. We'll go back to your picture and you can say, okay, we started with the wholes and the naturals. So you started with this inside naturals, and then we add on the 0 to make wholes, and then we add on the integers outside to include the negatives. Now we add on the rationals to include fractions. So everything out here, are they integers? So if you have a fraction like 3.5, that is a rational number. Is that an integer? No. Integers are 1, 2, 3, 4, 5, add 0, and the opposites. So you would say no, it is a fraction. It does not fit. Now the next question, some irrational numbers are integers. Remember, an irrational number is all by itself. So remember we had that picture over here. We've got our naturals, our wholes, our rationals, and then we have our irrationals all by themselves. So that is not true. Irrational numbers are never integers. So no, both of these are false. Okay, so I should say actually all rational numbers are integers. No, false. And some irrational numbers are integer? No, false. So just think about that diagram. All right, thank you. That's the end of lesson 1.